Sense and return mechanisms. Placing a circuit in a feedback loop requires sensing the output signal and returning a fraction of the result to the summing node at the input with the voltage or current quantities as input and output signals. We can identify four types of feedback: voltage, current, and current voltage. There are first entry in each case denotes the quantity sensed at the output, and second the type of signal returned to the input. It is constructive to review methods of sensing and summing voltages or currents. To sense a voltage, we place a voltmeter in parallel with the corresponding port. Figure A, ideally producing no loading when used in a feedback system. This type of sensing is also called shunt feedback. Figure sensing a voltage by a voltmeter. B, a current by a current meter. C, a current by a small resistor. To sense a current meter is inserted in series with the signal. Figure B, ideally exhibiting zero series resistance. Thus, this type of sensing is called series feedback. In practice, a small resistor places the current meter. Figure C, with the voltage drop across the resistor serving as the measure of the output current. The addition of the feedback signal and the input signal can be performed in the voltage domain or the current domain. To add two qualities, we place them in the series if they are voltages and in parallel if they are currents in figure. While ideally having no influence on the operation of the open loop amplifier itself, the feedback network in reality introduces loading effects that must be taken into account. This issue is discussed in session. Here you can see the figure A, addition of A voltages and B currents. To visualize the methods of figures, we consider a number of practical implementations. A voltage can be sensed by a resistive or capacitive divider in parallel with resistive or capacitive divider in parallel with the port A, and a current by placing a resistor in series with the wire and sensing. Here you can see these figures. Figure A, practical means of sensing and adding voltages and currents. The voltage across it. Figures B and C. To subtract two voltages, a differential pair can be used. Figure D, alternatively a single transistor can perform voltage subtraction as shown in figure E and F. Because ID1 is a fraction of VF, subtraction of currents can be accomplished as depicted in figure G and or H. Note that for voltage suppression, the input and feedback signals are applied to two distant nodes, whereas for current subtraction they are applied to a single node. This observation proves helpful in identifying the type of feedback. Thank you.